Okay, we're going to go ahead and get started. So this talk is, as you can see on the screen, this is Arduinos for us dumb software guys. So this is hardware hacking for us dumb software guys. I definitely include myself in this group. You know, I've done software for a long time, but I've never really gotten into hardware. So this is, you know, this is how I got into it. This is about a way that all of you could get into if you're looking for a way to do it. Just as a disclaimer, if you've seen other Arduino talks, there may be some things that are similar. It's because it's all true and good, not because it's, and I thought of it first, I guarantee it. So again, back to Arduino. So hardware hacking, it can be daunting for software guys like me. So I look at it and I say, you know, there's these complex circuits and components that I didn't understand, or even don't understand a lot of them still. There's the cost involved in getting into hardware hacking. So you have the you know, you have to buy development kits, you have to buy all these tools, soldering irons, test equipment, things like that. So you look at just the enormous cost you have to put down to get involved in this. And then there's also, in many cases, a steep learning curve. So you know, you're trying to learn assembly or something like that, these languages that may be hard to learn. There's also, for a lot of this stuff, there's a lack of good information. So you try to find, you know, good tutorials on things, and sometimes it's hard to find something. You know, it's equivalent to like an example in code where you can take it and you know, modify and use it however you want. But I still want to make cool stuff, and so I started looking around. So one thing that really helped me is last year I picked up the hardware hacking kit that they sold here at DEF CON, and I had a parallax board that's a really cool board, by the way. And then the other thing is I started just hearing about these Arduino things, just reading on Hackaday and the Make website and things like that. And so I picked up a couple of Arduinos and just started messing around. And so this is why I like Arduinos and microcontrollers, is they're a good mix of hardware and software. So you can drop code on them, and they can do the same thing as a really complex circuit, but they're just on this one little chip. And so they're really easy to use. And you can reprogram, repurpose them for something else. It's not like a circuit where you have to desolder everything, resolder it up. You just drop different code on it. It's something else. And I really like that. So if you look at this graph, this is just a graph that shows the search, the amount of the people that are searching for these different terms. So if you look, the green and the orange are Atmel and microchip. And you see over time, so these are two big chip manufacturers that are used a lot, especially in industry. And in fact, the Atmel chip is on the Arduino. But so as you can see, people have been searching less and less for these terms, but Arduino, the red one, has been going up since it came out, you know, in 2007 or so. Then it's, you know, steadily been rising, and it's past the other ones, and it's going to, as far as I can see, it's going to continue to rise because it has so many great advantages to using Arduinos. So what is an Arduino? If you're not familiar with them, they're open source hardware platforms. It's an open source hardware platform. It's an all-in-one solution. So it's open source, meaning the design is completely open source. Anybody can download the schematic. You can build your own. You can sell them. You can do whatever you want. It's completely open source. It's all-in-one, like I said. So that means basically have everything you need on the board. So you just plug a USB cable into it and go. You can just drop code on it. It has an easy-to-learn language. The Arduino language is kind of an abstracted C. It takes care of a lot of the functions for you, like digital pin writes and things like that. They're really easy to do in the Arduino language. It has a free open source IDE that does syntax highlighting. It uploads the code to the board. It compiles it. Can burn new bootloaders on just blank chips, things like that. So it's really cool. It has a strong community backing. There's a ton of people doing stuff with Arduinos all over the place. And there's great forums, things like that. And also they're about $30, so they're not for the typical one that most people use. So they're a really good deal, and they work really well. So to me, it's kind of like the hardware equivalent of a scripting language. So you know, you use a scripting language to get things done fast, to get things done easily. Scripting languages have disadvantages as well, though, right? You know, they may not be as fast as a compiled language. You're going to have certain trade-offs. You're going to see the same thing with Arduinos, but they're good for a lot of stuff. So this is a picture of an Arduino. This is a De Milanovi, which is 2009 in Italian. This is the latest one that the Arduino guys came out with. It runs on a Mega 328P chip. Has 14 digital input-output pins. 6 of them are pulse width modulation, which means they can be analog out, so they're not all the way on or all the way off. They go on and off so fast that it looks like they're part way on. And then you also have 6 analog input pins where you can read an analog value, 32 kilobytes of flash, and they run at 16 megahertz. And so, but what else is an Arduino? Like I said, these are open source boards, so a lot of other people make them. Some of them are fully compatible, other ones are just IDE compatible, which means you can drop the code on them, but they may not be, they may not be exact same shape, which we'll talk about why that's important in a minute. But so there's like the Arduino Mega, which is just a big Arduino. There's SparkFun makes some, the Arduino Pro and Mini, and others that they make that they're the same shape. They don't have the FTDI built onto it, so you have to have a separate FTDI cable. Evil Mad Scientists, they make one. Freeduino, Cduino, or other clones. Then there's some other ones that have extra functionality, like the FIO has some wireless capabilities on it that other ones don't. The Teensy is partially Arduino compatible. There's been other talks about the Teensy during DEF CON, and but it does a lot of USB stuff. It's really cool. LilyPad is used for embedding in clothing. It's a round Arduino. Arduino and Bare Bones are these really, they're just bare bones Arduino, so there's just not much to them. It doesn't have a lot of the extra components. And then the Maple is really cool. It's an ARM-based Arduino, and so it runs like 10 times faster, but you can drop the same code on them basically. And there's other ones that are also doing ARM-based Arduinos as well. And the Butterfly Uno is actually on a FPGA card, so it emulates the Atmel chip on the FPGA, and you can add input and output pins on the fly. It's pretty cool. So Arduinos, they're a general purpose platform, so you can make whatever you want literally with these things. So like this thing, I guess when you fart it changes the channel, so kind of funny. So I made things like I made a little autonomous robot that avoided walls. That was my first project. Took just like a couple hours. I made my daughter's Halloween costume with a stoplight that changed shapes, things like that. So you can make all sorts of things with these. People are making cool stuff. But like I said, they're not for every project. They're expensive when you want to make a lot of something. So if you wanted to manufacture 1,000 of something, $30 a pop is pretty expensive. You probably just want to go with the chip itself. They're not incredibly powerful. Like I said, people are doing cool stuff with these, but they're doing, you can do a ton with them, but it's not a computer. And there's no parallel computing. They do have interrupts though, so you can interrupt what you're doing and switch to something else. So in hardware, generally the first thing you do is the equivalent of hello world is to blink an LED. So here's the code to blink an LED. So I just define my LED pin to be pin 13, which on the Arduino board that actually has an LED on, like a surface mount LED there, so you can test it and do things like this. Then it just has a void setup function, and this is just the function that will run one time when the Arduino first starts up, and then it goes into this void loop where it's just going to keep going through this over and over again until it loses power or something happens to turn it off. So in this one, I'm just doing a digital write, which is going to make that LED turn on. I make that LED pin high, so that's going to give it power. I delay for 1,000 milliseconds, which is 1 second. Then I make that pin low, do another digital write. Then I delay for another 1,000 milliseconds. So it's pretty easy to make an LED blink. So now I just want to talk a little about shields. So shields, they fit on top of the Arduino as long as it's shaped the same shape. That's why shape's important. It adds extra functionality, and many are stackable, so you can stack one on top of the other. So here's some available shields that are pretty cool. So you have the Ethernet shield, which gives you Ethernet capability. XB gives you radio stuff. Motor shields lets you drive motors. Wave shields, you can play waves. Nixie tube shield, that's this guy up here. So this lets you drive Nixie tubes. So if you haven't seen them, they're a really cool display. So it has all the numbers kind of layered on top of each other, and then it just lights up the one that you need. I've been wearing this around as a badge a little bit, but it runs like 90 volts though, so I'm a little bit scared of it, but I still keep doing it. Then there's an LCD shield, so you can see LCD stuff. There's a cellular shield, so you can put a SIM card in it. You're on the cell network, you can program there. The advantages of shields, for the most part, unless you buy it as a kit, there's no tools necessary. You just pop it on and you've got that functionality. So for example, here's the Ethernet shield. So you just pop it on. In hardware, it can support up to 4 simultaneous connections. It has the TCP stack on hardware on the shield itself. And so this one thing you can do pretty easily. This is just a simple port scanner. So you just you define the the IP that you're going to scan by putting in an array, a four element array. So I just put it in there. So I'm just going to scan the subnet 192.168.1. And then I'm going to just change that last octet every time I go through the loop, and then scan ports, or just try to connect to ports 1 to 1028. And then I can report that however I want. I can log that to an SD card. I can transmit that somewhere else. So if I want to put this on a network, and then leave or something like that, then I have this really small device that I can use to be a port scanner, plant it somewhere. So here's the XB. It's 2.4 gigahertz, 250 kilobits max data rate, 128-bit encryption, and it can read from a few hundred feet to several miles in range, depending on the model that you get. So XBs and security. So one of the reasons I like XBs is they can be used for out-of-band communication. So they're a 2.4 gigahertz wave, but it's not 802.11, and so you're not likely going to see it like in a wireless assessment. So if you plant this somewhere, it's maybe going to go undetected for longer than a computer or something like that using a typical wireless protocol. You can also use these to reprogram your Arduino remotely. So if you can plant it somewhere, you want to change the functionality of it, you can maybe plant it somewhere it's doing one thing that's good, and then you're putting it as a Trojan or something like that. We want to change the functionality later, you could do it. And we're also looking at using this to do triangulation for wireless assessments. So say that you're trying to do a wireless assessment inside of a building, you're trying to figure out where that wireless signal is coming from, then we're looking at putting these around the building and being able to detect that way by triangulating the signals and the power they're getting from each of them. So here's the XB shield and the Ethernet shield together. So like I said, this is a small device. When you put these together, then you can put it inside of a network device. I'll talk about that a little bit later with the Cisco router. And you basically have this remote device you can use. So here's a picture of my Nixie tube shield. Since you guys probably can't see it up here, it's kind of small. So this one, right now it's just counting down. Everyone asks me what is counting down to when they see me, and I don't know what it is. So one guy was in the vendor area, it was getting down to like 10, 9, 8, and he was getting a little scared, it seemed like, but it just starts over. But anyway, so you get, but yeah, it's kind of fun. It's a really cool little display. So then the next thing, after you use the available shields that are out there, the next thing I thought about is, okay, I'm going to start making my own shield. So you can either use what's called a prototype shield, where it's this shield that just has a bunch of holes you can solder into and use like that. You can use a custom PCB where you draw it out, send it out to be manufactured, you make it yourself. Or you can use a multi-purpose PCB like a perf board, which is what I tend to use just because they're cheap and I'm lazy and they work well. So you're going to need a soldering iron, possibly other tools if you're going to be making your own shield. And one thing I want to say about soldering irons is if you're having a hard time soldering, just try it with a decent soldering iron, because that was the difference for me. As I was using a cheap Radio Shack one and I sucked, and now I can actually solder because I got a decent one. So reading from pins. So digital reads, they're really easy. So you use the digital read function. You're going to get a 1 or a 0 if the signal coming into is high or low. With an analog read, you're going to get a value between 0 and 123, depending on what's coming into it. So one thing that you want to think about anytime that you're hooking into an external device is that it's kind of like the forms in a web page, right? So you've got these inputs, and you can start just pushing weird stuff to them and seeing what happens, and it kind of fun stuff happens. We've seen other talks about doing things like USB fuzzing, so you just start sending it crap or trying to tell it you're a different device, and a lot of these interfaces aren't as well protected as the front door is, and so this is a good opportunity to use these hardware platforms to do hacking stuff. So here's one little project that I made. This is one of the first things that I did. It's a lie detector. So we're going to be running a little bit of voltage through people to do this, so be careful. This is just a little bit, so it shouldn't hurt anybody. But so anyway, so the wire, you basically take you have two wires. So you hook. You take a wire, you put tinfoil on the end of it, you wrap it around your finger, and then I just use tape in this picture. You can use Velcro or something like that as well. You plug one of them into 3.3 volts, and then you take another one to another finger, you plug that into an analog read. Use a 10 kilo ohm resistor as a pull down to help you get a good accurate read. So from the analog read to ground. And then basically the way it works then is, so you've got a piece of tape on one finger with foil with a wire coming off of it going to power, the other one going to the analog read.